Good morning, especially to those in Australia. Good afternoon to you all. Welcome to the webcast. Time to start. It's a quick one, so not much introduction and those things. We'll get into the matter very fast. First of all, what is all about? So we are having a chain of sessions at the tag of train and try. One of them is happening today, wherein we learn a few capabilities, or if I put simply, how to use simulation standard. Thereon, you can request for a evaluation license of this product. You can try these things on your own, and should give you a good feel of how this software can be applied in your domain. Introduce myself. I am Kapil. I'm Kapil Gaitonde. I'm the Territory Technical Manager for Simulation Products based in Singapore, and I'm covering all the South Asian countries, Australia and New Zealand. Start. First of all, why simulation? Why do we need it? Let's take this simple example. A typical process that you might be already following in your company, where you have the CAD model, you do the designing in the virtual front end of CAD. Thereon, you build the physical prototype. The actual prototype is created. And finally, we move into testing. We want to check if this prototype works, if there are any problems. Unfortunately, if there is any hiccups, any problems, then we'll have to recreate the design, do appropriate changes in the design, and this cycle goes on. Obviously, a prototype is an expensive affair and it takes a lot of time as well. So that what we are speaking today is more towards this, wherein we have the CAD model, we virtual prototype, so we have a working mechanism built in the software virtually. Then we can simulate it, we can test it, we can see how this product behaves or functions or what is the performance virtually. And of course, if you are not satisfied or this is virtual, you can do many iterations in the software without much cost on the manufacturing. You can come to a very good or a final working condition which you think is fine and you have concluded virtually. And once everything is done, if at all necessary, you can try to do a prototype and check if your conclusion from the software is fine. So definitely this should give a perspective of what we are looking at, how this can add value to your entire design process. Now, what should happen when we implement such a process? Obviously, we are looking at a very high quality and performance of the process compared to what it was before, and in a shorter time and at a lower cost. This obviously lead to faster, better, and very good products. Now, what solutions that we are talking on today, or what are the different products and the portfolio of simulation solutions that we have? First, we'll look at solar simulation. Rather, this is what we are going to discuss today in more detail, especially a small part of it. It's more of a structural analysis software. You can do structural analysis, thermal analysis, understand the behavior of structures under different loading conditions. Let's go a bit more detail a few minutes from now. But before that, we'll have a look at the other products that we have. The second one is for fluids, what is called as SolidWorks flow simulation. It can simulate liquids, gases. You can understand the velocities, pressures, and the forces that these liquids bring on the components or your product. We have a set of products by name SolidWorks Plastics. This is more for manufacturing, understanding the manufacturing defects that might come when we manufacture plastic parts. It can also be used for designing of molds and deciding the molding details. And finally, we have a set of products by name SolidWorks Motion, which is more of a kinematic analysis tool. You understand the working of such mechanisms. It could be any kind of it, not only in the form of animation, but also in the form of forces, torques, etc., which come in different components. We will also have a quick look at this in due course of time. In fact, all these products are integrated in SolidWorks 3D CAD. So there is importing, exporting, no multiple softwares working, but they all work in a single front end. Thereon, they are coupled simulation in the sense these are not only integrated with CAD, but also integrated or they talk to each other. That is, if we can talk to the CFD software and other way around, you take the load from motion and take it to structural simulation and do further finite element analysis. analysis. Finally, it is all easy, it appears very easy to use, etc. But say that it is actually very powerful, it intuitive, there is too much of training required. You can say in the next 20 minutes, you should be comfortable to start using simulation. It is robust, it can handle many intricate difficult situations. And it can handle many different iterations. So get into the product that we are going to discuss today, what we call as SolidWorks simulation, which is an finite element analysis tool. And this is a tool which should help you in simulating or testing the virtually. One of the capabilities, or go specifically into the capabilities, I'd like to highlight what we're going to learn today is on these 4 capabilities, which is under a product by name simulation standard. So we learn a bit of analysis, kind analysis from motion, for this, that is understanding the life, and finally a tool called as trend tracker. Let's how it helps in deciding these details. So back my pointer to full screen, and let's see what is static analysis all about. So as the word says, or if you see the images over here, we have a case wherein this particular part is loaded under different loads. Also has a case wherein the rips inside this part, which you can see, let me my pointer, which you can see here, are a bit different. And from the words you can understand, the first tool is without rips, the second has rips, third one is actually having more deeper rips. Obviously, as a designer, I want to understand which of these particular tools is better, which makes more sense to be designed and manufactured, and we obviously need a tool for it. And like simulation can help you in understanding and doing that kind of thing. Now, if you see the below results over here, with no rips has a factor of safety of 1.37, and with deep rips is actually far more stronger. However, I'm happy with a factor of safety of around 1.5. This should be good enough for me for a application like a stool. And if we consider in terms of cost, you can see the variation that is happening. So though I'm increasing the cost by around 8%, but actually I'm getting a good strong stool which may avoid any failures on the field. However, I don't want a more stronger stool wherein I'm actually spending 18 and more than the original design. So if I have to take decisions like this wherein I want to conclude on what is the best design, then a tool like Solid Simulation can help you. And let's get into the software to see how this particular thing works, how it might help you. Software, the step you now will be helpful yourself do it on your own, and you see how intuitive it is. Before that, I think I'll also trigger a poll which will help us get to know who actually wants to go to the evaluation process. It will be open for all 20 plus minutes. So feel free to take your time and as and when possible give your feedback here so that we can arrange for the evaluation licenses. Let me get it good. Looks okay. Fine. So let me close this. Let me come back to the software. So once the software is started, there is a particular tab at the top called as SolidWorks add-ins. Ensure that simulation is activated over here. You can open a blank file. There we are help, solid simulation and tutorials. If you default tab that comes up over here, and if you scroll through a little bit below under static analysis, that's what we are discussing now. You will take the first example, which is on analysis of a part. So example, I'll part. So it is very even. You may not need anybody's help to do this. You actually follow the tutorial and do the analysis over here. In fact, there's one more option which I would like to highlight, which will also be helpful in your initial learning phases, which is as study advisor. You see on the left top over here, I'll just trigger and show you how it works. here it is asking a chain of questions which will help you guide on what kind of analysis to be done, how to do it, and the process for it. So this I'm not going through this because I believe you can do it on your own. But to have the software, please explore this option. That should also give you a good perspective how to do an analysis. Let me go back to this setup. So you can see it is a normal bracket. A particular material is already applied in the part of it. Later on, I create a new study. So when that I get this particular front end where I can give a name to the study. I can decide what kind of analysis that I want to do. Moment probably I'm selecting stack analysis and accept it. Okay. That, and I'm following the exact steps that given in this tutorial. And you are doing it on your own, you can do it. But typically what I showed you now, I created a new study which was a static analysis. Then I'm applying fixtures. Okay, just let me go back here and let me apply fixtures. Typical part is held. I can select the appropriate locations and tell the way it is going to be held. So it can be either a fixed geometry, the animation at the top left is showing that. It can also be a roller slider. It could be a rotate connection over there and free to move. It also be a hinged connection. A few other different cases are available here. So you may not, or a user is not required to understand or decide on what kind of current has to be used, but can directly jump onto, just visualize the things over here and apply them appropriately as per a designer's understanding. So this is what is one of the steps. Thereon, obviously I want to load this setup at certain locations. So as shown in the image over here, the green part, that is this surface, I'm to load it with a force. Okay, let's take a particular force, right click force, and a particular force. Now you do have different options of selecting the units here. You can do that. You can also have a non-uniform force. You can also have decide the direction of the force. So there are two different options which are present here, which you can explore. Apart from normal forces, you also have the option of applying a torque. So you give a reference on which the torque will be applied, and that torque can be applied appropriately. So this is the second step, I would say, that is done. And after we can directly run this particular setup, what we're solving it. So as you saw, we may not be required to think too much on the meshing part of it. Software has its own capabilities to decide on the appropriate mesh. Saying you actually control a huge number of things in meshing, but I'm not covering them today. But those options are available in the software. So how it looks, a simple stress analysis has been done. I have used a particular metal alloy steel. I can try changing different metals and check it. I can change the dimensions and verify it. So all the iterations can be done on this setup. In terms of results, we can see the stresses. We also have the option of seeing the deflections, also see strains, and there are a huge set of different results that can be checked. So when you're doing it on your own, you can scroll through those and you can find out the relevant inputs or outputs that you want from the software. So this is what it is all about, a simple structure analysis. I take this example again, which will help you understand which is the best design for your setup. Let's move on to what is of kinematic analysis. If animation is visible to you, it's a certain part moving. So saying that it is not animation, but is actually the variation of forces and torques that are happening when this part is moving. So this is this is a tool which can help you simulate such mechanisms. If funky or nice animations are present here, which can tell you the capabilities of this particular module, so you can simulate such nice it's a nice latch mechanism. You want to decide the proper length of mechanisms, those can be done. wherein say if it is a process, you want to visualize the working of an entire process that can be done. So it is a tool by which you can first of all design such mechanisms, and you can visualize it, and finally you can also understand the forces or the torques that are coming at different locations. Let's have a look how it works in the software. Actually, again, a complex theme. I am going to the same location of simulation tutorials. Let me try to take an example. I am taking the first one, which is a mechanism. You can see here. So a simple is present here, which is working based on the rotation of this particular camshaft. This one is actually a spring is acting over here, which is simulated. I'll show you how it looks. So let's here activate the motion tab. It is as shown below. Again, from the SolidWorks add-in and activate motion. I can go into motion, and before I show you about the setup, I will directly try to show you the result. Which came up for a few seconds is actually a virtual spring, and I can actually visualize how this part is going to rotate. That shows you what may be a kind of output. Now, of course, this is animation. Let's have a quick look on how and what this setup is all about. Let me make this bigger. Okay, I'm trying to do it, and so one is the motor. Motor is nothing but one which is telling at what speed the shaft is going to rotate. So in case it is 1200 RPM. Thereon we have contacts which are telling what are the two parts which are in contact conditions and how they are going to work. Okay, and then we have one more set of contacts, somewhere big camshaft and the rod which is going up and down. And there is a spring, as I told you, which is working down here, which is the motion or locking, giving the stiffness necessary for this part moving. So this is what it is about, and for the animation, but more important would be in the form of results. Let us try to take one of the results here. Let me try to plot a particular contact force which is coming somewhere down here, right? Let's plot this. So it's something like this, telling us the contact force that is coming at between those two camshaft and the shaft which is rotating. Now, this is one part of it. We're understanding the reaction forces that might be coming. I can use this to design further details of this part, understand it, and do further analysis. But in this mechanism, I want to rotate this particular thing at a very high speed or more than what has been done here. That is 2400 RPM, and let me calculate it. Obviously, it would be quite fast. The calculation to be like that, but the part moving fast. Let me play it. As you can see, I'm having a scaling factor of 0.1x. Okay, so that's how it looks. Let me try to see the results now. Wow, difference. Forces have come a little bit lower, but actually the force, the speed is so high that the reaction forces are going as 0. So it's wherein this component is actually flying off from shaft, and which is not desirable. I want to ensure that it is always in contact with that particular shaft, and decided I can just I might want to change the stiffness of this particular spring. So probably from 1, let me try a very high stiffness of 10, and let's calculate this again. We'll go through the same steps which I showed you a few minutes back. So as you try it, please feel free to go through these things in detail. Those will use the same topics which I discussed in this software. Yeah, the reaction force has gone up. The thing is actually working. The camshaft and shaft are actually in contact with each other throughout, and that's understood from the forces that are coming here. Of this, we might be required to have a more stronger shaft which can withstand these levels of forces which are in the tune of 400 newtons. So this is what motion is all about, and it should tell the capabilities, the way it works, etc. Now let's move on to fatigue analysis. As this is more of a module which can help you find out the life of a component under repetitive loading. So given component, if it's subjected to a compression tensile load frequently, then we can want to find out how many cycles it can withstand. We can use this module to find out. What else? It is basically comparing the stress variations or the mean stresses with a particular diagram called as SN curve, which is but the mean stress divided by number of or the amplitude stress versus the number of cycles that they might fail at that particular amplitude of stress, and that is used for understanding the life of a component. So the works is very simple. Example again from the tutorials. To show you the mechanism from which taking this particular case. So let's have a look at this particular mechanism which is on the screen. It is that of a ramming mechanism, which you can see here, wherein the part is ramming something below there. Let me try to reduce the speed and show you for a longer time. The part which can be affected because of to and fro loading is the component which is shown here. So if I stop it and show you this one, this particular component. It is also I want to understand what are the forces that are coming in this component. So in over here we have an option by which I can import the moment loads into simulation. These loads can be taken on this particular part and I can do a stress analysis, and that's what we are going to do here directly and see how it works in analysis. Let's open that part. Here it is. This is the mechanism which I showed you. Let me open that part directly. This looks to import the load. It looks like this. It will have import a gravity condition. It will bring in the centrifugal forces, and it brings the forces which are acting on both the ends of this part. On this part, I can stresses and deflections which are coming in this part. I believe now you are comfortable how they look and what they are all about. So how it looks. They just created a new study for static option. I also create one over here for fatigue analysis. Loads can be as that what I have shown you now. So be variable, that is they can be random loads, can be harmonic. They can also come from a random vibration analysis. So these different options are there. I am taking the first option now and proceeding. After the kind of loading or the number of cycles this particular component is going to be subjected. So probably I'll take the default value of 1000 cycles. You can try with different cycles. If you can scale the result, you can decide how it is going to come, whether it is a fully reversed loading, that is it is going from positive to negative, or it is zero based, or any of these different variations can be understood. So this is what it is all about. And I missed out on something, that is the SN curve. Software is a certain set of materials wherein the SN curve is already given, or you can also derive it from the ASME course. Both the options are available in the software. If your own curve, you can also input it over there. So based on that input and the load conditions given over here, we can understand the damage that is happening on this part, the damage that is happening, and we also understand the life that remains in the part. So this can help you design a part for a certain life. You want to ensure that it works and it does not fail. Other way, you also want to ensure that the part is not over designed and it works far more than what it is expected to work. So this is all about fatigue. You saw that it works. Finally, this would be the last topic for today. This is what you are going to learn. One of the final topics that you are going to learn today is something called as trend tracker. Let's see what it is. huge amount of text. I'll not get into this text, but I think better would be I show you in the software, and here's how it works. Let me again go back to my tutorial. Professional trend tracker, I'll open a particular example. Let me close this, make green so you can see it clearly. Here it is. So a simple setup is present, probably similar to what you saw initially. I trigger a solution. Okay, so these are there typically displays, etc. Now, as a designer, I want to try out different iterations on this model, and also want to understand whether those iterations are actually leading to an improvement or it is actually making the model worse. So let's go in this module called as trend tracker. I just activate it. On hitting, you'll get a extra feature down here when it looks something like this, and set the present results as the baseline. So are my actual present results, which you can see here. Now, as a designer, okay, first let me show you how it looks. So at the moment in this a graph that is coming up over here, we're actually seeing one particular result. Now, as a designer, I am lost. I want doing different changes to this model. Let's try doing a change. I change this dimension from 8 to 10. Let's test the model and I solve it again. Okay, fine. So I have a result. Look, if I understand, I think no, 10 is too much strong. Let me change again. I change it to 6. Fine. I build it, fit it, and solve it again. So iteration where I started off with 8, then I went to 10, came back to 6, and now I'm lost. I don't know whether I'm improving the model or I'm actually deteriorating, and it is a question. So Trend Tracker is a tool which sits in the background over here silently and is going to tell us how the trend is happening with these changes. Have I actually improved the model or have I spoiled it? So here it has stored the mass variations for those 3 iterations. You can see. So obviously when I increase the dimension, the mass has gone up. But important would be stresses. Let's see how the stresses have gone. Like this. They've gone below at a certain level, and then again gone worse because we have gone the dimension, and finally displacement. Same over here. So this is an interesting tool which keeps an eye on the design changes that you're doing. Finally, you can get a good feel of how whether you are actually improving the design or something is going wrong. You can also have an understanding of or the right changes that need to be done. So this is all about Trend Tracker, and it's how it works, the direction in which we are going, whether we are improving or deteriorating. So a few capabilities which are present in the simulation standard module. I have got those 4 different capabilities. The polling window should be open. Feel free to give your feedback. Let us know what else you want to learn. Also, if any inputs for us. Most important, let us know if you would like to try this software on your own. You want to try these 4 different kind of analysis and get a feel of how you can apply it in your end. So in the coming sessions, we'll be having a few more topics on professional. Well, I'm not covering all these things, but I'll try to cover something on thermal analysis, opposition, and probably frequency analysis. And finally, we'll also have a session on premium where I'll show you a few examples how to solve a nonlinear analysis. So we'll also try to do some examples on that. And there would be 2 more sessions wherein I'll try to get you a feel of flow simulation and plastics. So what is in store in future? You should get emails from us on when these sessions are planned. You are well joined, and use the session for your best advantage. So that's it from our end for today. The polling window should be open. Please feel free to give your requirements, inputs, etc. over there. Second, any questions, any doubts, use the chat window. That I'll try to take and answer most of your questions. That's it for now. Thanks a lot for attending this session. Hopefully it was useful for you. Hope to see you in the next session. Thank you very much. So ask the questions. I will try my best to answer now. If not, at least get back to you through email. There is a question which says that how do we download the demo version? Actually, it is a bit of involved thing, so please give us your input from the polling window. We'll get our local partners in contact with you. They will help you with the software as well as the necessary licensing thing for you to use it. They have different options, or based on your requirements, we can arrange for the license. And what is done, you should be ready to go. So there is no automatic process by which you'll be downloading from an online link, but get along our local partners with you, and they should be able to get you going. Okay, are flowing in. Let me check them and answer. First of all, simulation, how many of these simulations are included if with SolidWorks Professional? Well, SolidWorks Professional, we are not including any of the simulation capabilities. The simulation products are a different set of products, as is saw here. They are integrated in the sense they work together. They have the same front end as you saw now. But the package, it is not available inside SolidWorks Professional. So it has a different product in itself. Check out other questions around here. Yes, I have got a good feedback. I need just going to restart on. Okay. Okay. In the okay, you is asking, actually the stool example which I use is plastics, and by default obviously we need to use non-analysis for plastics, but saying for all practical purposes, and if these are not huge, we are not talking about plastic deformations, and if it is acceptable to the user, wherein you are actually playing with a very high factor of safety, it could be 2 times, 2.5 times, or above that also. In such cases, it is fine to assume a nonlinear analysis or a nonlinear material to be linear and get a feel of what is working. So this case wherein, as you saw, we are comparing between 3 designs and come to a conclusion on which better design. But could be a case wherein I want to understand the absolute value of stresses at a certain location and get a good feel of it. Then obviously I need to do a detailed nonlinear analysis to understand understood behavior. So you are right in saying that it is plastic material, we need to use nonlinear analysis. And in due course of time, we'll do that as well. We'll try to get a few trainings on nonlinear. What's the difference in nonlinear analysis and the one you showed? So if I put it for the one that if I compare it, the biggest difference would be material behavior. In that simulation, I have assumed material is going to be behave in a linear way, or is basically driven by Young's modulus. Where in a nonlinear, obviously we are giving the stress strain curve and doing a detailed analysis. So obviously nonlinear analysis would be far more accurate than this particular thing. to know it was an informative seminar. Let me go ahead. The present version, can you view it, make it 30 days, 15 days is very fair. Trial version, definitely do not worry. We want to ensure that you are comfortable with the software. We'll arrange appropriately. So feel free to discuss in more detail. First of all, ensure that you are told in the poll that you want to go in for a trial version. Thereon our executive will get in touch. Even if anything has missed out, feel to email me or our marketing executive. Ensure you are comfortable with the software and get a feel of how to use it. Much cost. So one guy is simply asked, what is the cost? Does this allow nonlinear structural analysis? Okay, first of all, no, the simulation standard will not allow nonlinear structural analysis. It is only linear, and it is also static analysis, so it is not time dependent. And so cost, frankly, I would refrain from discussing here. Neither am I expert in that. So once the partners are in touch with you, they should be able to give you all those details. Is that to do relation on part same with step to do in assembly? Yes, the steps that we followed here are absolutely same for a part or an assembly. It all is same. So that differentiation we are not kept, and it is seamless. One can just the same steps for a assembly or a part, and it can help both of them equally good. I think question I will wait for a supplier to let me know. Okay. I'm interested in simulation accuracy to would require nonlinear analysis. Is this part of the standard package? I'm interested in simulation. So in terms of accuracy, which is that we are using, it could be simulation standard, professional or non-premium. All these are highly accurate. Whatever results that are coming are best standard. We have enough documents to prove how good it is in terms of the solving capabilities and also industry-specific examples. In nonlinear, as I mentioned, unfortunately, it is not packaged in simulation standard, and it is available in the simulation premium module. So okay, I'll quickly go back and show you that, but in the meanwhile, I'll just go through other questions in here. What is this included in SolidWorks Premium? Okay, SolidWorks Premium has a few capabilities. If I put it simply, today we saw 4 different capabilities, where SolidWorks Premium has only 2 of those capabilities. And if I put what cannot do, it cannot do fatigue analysis, it cannot do the trend tracker thing they showed you today. How to simulation and simulation. So please leave us posted through this poll. Our executive should get back to you very soon on what you and explain you in detail. If you should be seeing my email below here, feel free to contact me. I'll get appropriate person in contact with you. If the standard is standard included, or I have to purchase it separately. Yes, unfortunately, we have to purchase it separately. The standard is not having the simulation standard capabilities, and we might be required to purchase it. Okay, from where can I get a detailed training for simulation? Okay, fantastic. So for a starter or someone who is absolutely new, I would suggest these online tutorials. They are more than enough. They can get complete understanding of these details. There is also a theory manual over there where you can understand how FEA works. Saying that, we also have trainings which are frequently happening at our partners. So if you are interested, you can try to join one of them. So as and when a partner contacts you, you can tell him on what particular training that you would be interested in, and he should be able to provide that training. Do I set up a headset going to restart my laptop in the preparation to show the example? I've taken most of the questions. I mean, which best in the down marine boat heading? It is such as buoyancy, waterline height, drag, hydrodynamic lift. So in terms of this question, which is more on which simulation software would be best for determining marine boat hull design details such as buoyancy, waterline height, drag, and hydrodynamic lift. these are more of what we call as free surface analysis. In terms of software, the flow simulation has certain capabilities by which we can do it. But in that, I would prefer discussing it in more detail than giving or no answer to it at the moment. Okay. How can you determine the process of flow simulation? Can you send some information to me by email? We'll note down your email, and we can definitely get you along with that information. Let me copy your email address. Okay. So here, I think I have answered most of the questions. Saying that, there is one more question. Let me check. If you get a trial code, is it active only during a certain period of time from when issued, or can you wait to use it at another time, but for some duration? Yes, like there are different ways, but it would be good that you specify when you want it to use or when you want to explore it, and we arrange trial version around that time period. That would be better. Obviously, we all know that we are busy, and sometimes happens that you take it, but you are not able to utilize. So there could be different scenarios. We'll ensure that you get a good feel of the software, irrespective of when you want it, how you want it. We'll try our best to get it going for you. I saw a few questions coming on the product range and this thing. In terms of hull designing, say, let me take a pointer down here. I believe flow simulation should be able to help you to a certain extent. In terms of capacity, if I go in here into simulation, so what we have is nonlinear. Now let me quickly show over here. So these actually the non-linear capabilities wherein you can simulate components like rubber, plastic, foam. You want to understand the permanent deformation. So capabilities are actually simulated in the simulation premium module, and you can understand it in more detail over here. You can see it. So detailed analysis, something like this. This looks that way. Okay. Detail that you can understand in non-linear. It could all be time dependent. Something is the shock loadings. Some load on a bridge, you want to understand the variation over a period of time. Harmonic is something like this. And random loads or seismic loads. I'm going to go in detail in the coming sessions, so I'll not discuss too much. But at a broad level, if you see the capabilities, it looks like this. So standard has more of those static capabilities and static fatigue. Prism you saw just now, which can do nonlinear, dynamic, and dynamic fatigue as well. That is estimation of the life under fatigue load. There are professional has capabilities like optimization, thermal temperature distributions, and thermal stresses. You do frequency, find the natural frequencies. You can link, and these few different capabilities are present in professional. One interesting thing should be material portal as well. There is a tie-up with a company by name Materiality, from whom you can actually download and use a huge set of materials which are available online. So I believe this slide should give you a feel or understanding of different capabilities. If you have any questions, let me check. I think a few more questions have flown in. Let me check it. Okay, more questions have come in. Let me check out. Do you have a model 3D tool to allow to be more easily set up in, for example, nodes for modeling welds and also mating surfaces from manufacturing model? So in terms of optimization, more question on pressure vessels. These two would be what I would cover in the training sessions for simulation professionals. But saying that, let me just try to get these chat windows on this side. Yeah, it is. So optimization, it is over here. So this module has capabilities by which I can do a parametric optimization. I can do software the variables that I want to optimize, and then the software can do the iterations and give us a final model which is an optimized model. So this capability is present in Simulation Professional and it can do it. In terms of capabilities, if I have to quickly show you vessel, it is something like this. So it ability to give us the linearized stresses across a particular cross section. We can understand the stresses as per the requirements of the ASME vessel codes, and we can compare it with that code to understand in detail whether the component is designed as per the requirements of that code. So quickly tell you something about pressure vessels, then what it is. Optimization tool to allow to be more yes, the optimization tool that we have is very robust, easy to use, and it is well integrated. It will directly use the parametric model created in CAD, so that makes a big difference. You can optimize on many features. There is one more question which is more towards nodes for modeling welds and also mating surfaces from a manufacturing model. Okay, I could not grasp this part of the question. So it's like, for example, moving FA nodes for model weld. No, Frank could not grasp a certain part of your question. So I would request you, especially the optimization question, and drop me an email. Then I'll try to understand it in more detail. What is it for materials? Okay, the website for materials is called as Materiality. If it is present on the screen here, this is available for Simulation Professional customers. They can actually download a huge set of materials other than what we are giving in the software. You can access it from the software. So if you show something, let me try to open it, covering it in more detail. So if you have Simulation Professional, when you go into editing of material, you should see a link to this website. It will automatically check your authentication with your serial number and open the module in the software. So let me try to do something quickly and show you how it works. Any other questions, guys? Look, now so a few more seconds by when I can just open the software and show you the modality options. But I think that's it for today. Thanks a lot for your time. I realized that actually we spent more time on questions than the session. Nothing wrong. It is all for you. Feel free to use this opportunity to interact with me and be fun for it. So I'm there in the option to show you the materiality. So once I'm in the editing option here, at them you can see. Oh, okay. Coming in the center. So I just so the bottom you can see the click here. I say okay. It goes. You can see here my dot materiality, and I can actually. This is the image. This is not image. The image is what you saw in the presentation. The true thing wherein you are actually selecting the kind of analysis that you want to do. So they are directly shortlisting based on the analysis. It is the kind of material that you want. You can decide the class of the material, etc. And you can there are 4 different material databases from which it can actually shortlist for us. And so here it is. It listed these different materials from the website. You can click any one of those, hover on those things to see the details. Click and it opens one more page which should give material. You can just keep it through. It's all yours, and you take different purposes. But the capability or the feature has been given in Simulation Professional. Those customers understand subscription, get this by default. Let me keep the holding slide so that you know whom to contact. Oops. Not. So thanks a lot for your time, guys. If I missed out on any question, feel free to email me to the email one below, and we'll get back to you. Hopefully, all of you have given your feedback through the polling window. Hope to see you soon in the next session, which should be more on simulation professional. We learn on thermal analysis, we learn optimization, and other features like probably I see a few of you are interested in thresholds. Probably I'll also try to do something on frequency analysis. Okay, thanks a lot. Meet you soon.